Hi folks, this is the video solution for problem number 3 of the midterm in lab section 53. As you can see, this is a problem that has to be done with a hybrid approach. In other words, you have to use the solid elements, the shell elements, and the beam elements, all three of them in the same model. Okay. The way it's set up is that the edges A, B, C, D, E, F, and G, H, these are all clamped. These four edges are clamped. And the top face, this top face of the solid is subjected to a pressure of 2 psi. You're asked to identify the number of planes of symmetry. So obviously there's symmetry this way if you cut it like that. And there's symmetry this way if you cut it like this. So you need to model only 1/4 of this problem. And you have two choices. You can solve this problem as a single part, or you can create an assembly made of three parts, the three parts being what is going to be the beam, what is going to be the shell element, and what is going to be the solid elements. I will follow the same first approach. Okay, so let's go ahead and make it. So let's start with the part file. And immediately I'm going to save this file, save management, save as. This is on the desktop, a new folder, and I'm going to call it Midterm 53. And just to remind myself, this is going to be hybrid problem. Okay, so we put this thing in it. My first task is to make that solid object. Now, because that block in the middle, because I'm talking about the solid object, but you really should be in part design in order to pad. Okay, so on this plane, I will sketch. It's going to be a rectangle. It's going to be a rectangle based on the dimensions that I have there. It's going to be 4. This side is 4. This side is 4. And that side on the top, let's see, the drawing says that side is 2. Okay, and we're going to exit. And okay, so let me change this thing slightly. Let me make this thing 2 and this thing 4, so that it comes out in the view just like what you have in the paper. Okay, 2 and 4. Exit. Okay, now it's better. I'm going to pad this by the height, and the height is 3 inches. Okay, and now on this face, I will sketch half a circle, because remember, we're doing 1/4 of the model. So this piece, there's a half a circle here, and we'll clear it up in a minute. Okay, first of all, the radius of that guy, the radius of the circle, based on the drawing, radius of 0.5, 0.5, okay? And it's symmetrically placed between the top and the bottom. You can either put a dimension or you can use a constraint. That's up to you, entirely up to you. I'll use constraints. So top line, control bottom line, control the center, and I'm going to make it symmetric. I'd rather equidistant. I'd rather use these constraints instead of dimension, but you could have made dimension equal to 2 from the center all the way down, or 1.5 actually. Okay, so we want to make a pocket all the way through, all the way to the last, and there we are. So this is what you see there. Okay, so we are good here, and that's our top part, a quarter of our top part, of course. Now we're going to create a point here, which eventually the beam is going to go to, and the that's the point C. If you look at the drawing, the coordinate of the point C is on a wire 4. I think that's better. Yep. Yep, that's good. Okay. So we need a line. We need a line from here, from that vertex to this. Okay. Excellent. And now we're going to make that surface. So on that horizontal plane, I will sketch. Okay. So the circle is centered at, let me see, centered somewhere here. Let's see now. This, okay. So you gotta look at the drawing. Look at this drawing. Okay. So the center is over here, which means in this direction, the center is in this direction. There is 2, and y is 0. So we create a point. Let's see now. Horizontal, we put a 2, vertical, and now we're going to do a semicircle with this origin, and it goes like this, and we're going to clean it up in a minute. Okay. So I'm not 100% sure whether this point, yeah, see that this point is not coincident with that. Control that. Let's make it coincident. Okay, very good. And yeah, okay, and the center is right here. Now we need another arc. Center here. Did I pick it? And we'll clean it up like so. Okay, let's dimension these things. Dimension of this is going to be 5. That dimension is going to be 5. Okay, let's clean it up. So we need to close this, and hopefully it's vertical. It is vertical, as you can see. And another one here, going from there to there. Okay. Now this point, I can either delete. Yeah, please note that I ended up deleting that point instead of, remember I created a point there in order to be able to find the center. I deleted that point. See, there was a point here. I deleted that point that I created in the in the sketch. Okay, I deleted that. Okay, so now we can close it. There we are. We're going to make everything out of steel. Everything is made out of steel. Okay, and we save it. Now we're going to go to generative structure analysis. CATIA immediately meshes this guy. So let's change the rendering here. All right, already meshed this solid object. Now we're going to do the shell, mesh the shell. And there we are. Yeah, that's okay. And then we're going to use the thickness of, right, 0.1. Thickness is 0.1. Please notice that the thickness is specified right there, okay? Right there, 0.1. Okay, so thickness is 0.1. Very good. Now we're going to mesh the beam. Mesh the beam. This. Yeah, 0.25 is good. And then we create a 1D property for that, circular, and you're told that the radius of that beam is 0.05. 0.05. 0.05. There we are, 0.05. You say OK. We then have to create connections between these points. So connection, let's hide the beam. Our first connection is over here. And for the second component, I select the end of that beam. Bring it in the show mode. Hide the stuff that you don't want. Hide this white dot. And there we are. That's our first connection. And this is going to be rigid. And do another one down here. So another connection. Let's hide this surface. Let's hide that sketch. Let's hide that point. First component is right there. And then we bring this surface into the show mode. Now we're going to hide this line. We're going to hide this dot. And this is the second, the second component. Hide the dot, hide the dot. There's the second component. Okay. And these are both going to be fastened. So here, not fastened, sorry, rigid, not fastened. Vertex to vertex, you cannot have fastened. So rigid, the first one, rigid, the second one. We say, okay, let's get these things back. All right. Now, the restraints, surface slider, on this face, on that face, and on that face. Okay, very good. Then this edge is in the plane of symmetry. Why is that plane of symmetry? So we go to user define. This edge is in the YZ plane of symmetry, does not move in X. Rotations opposite. The other edge on this side, this is in the XZ plane. XZ plane means that it does not move in Y. Rotations opposite. Okay, and finally you put the pressure up here. The pressure was, you were told that it's 2 psi. Okay, the fact that on that top face, the fact that you're taking 1/4, the pressure is still the same. Okay, so I think that's it. Let's save our analysis. File, save management, analysis, save as. This is the right folder. Yep. And I'm sure this is going to run. Yep. It was vertex to vertex rigid. It's just that, okay, so this is going to, it's moving as a rigid body. So let's see what the issue is. Something we have not done properly. Let me see for a second. Did I clamp anything here? I was supposed to clamp. Oh, oh no, wait a minute. Right there. No, where's the restraint? Okay, these are okay. This one, I forgot to clamp that end. Actually, I made a mistake here. This should have been clamped, not user-defined restraint. So deactivate this. Okay, this restraint, not this one, the other one. See, bring this in the show mode. That guy should have been a clamp. Things like this happen, you fix it. That's all. As simple as that. So let's bring this thing to the front. This edge is clamped. That's it. Now it's going to run. Done. Okay, let's reset the scale. There we are. And you can animate. You can see the beam is bending. You see that? This is fairly bulky, so basically very little stress appears here. And this is kind of, it's stiff because of this clamp and everything. You can look at the deflection. There's a deflection. As you can see, the block is moving down pretty much as a rigid body. You see this? Let's change this thing to material shading. Average ISO. There we go. It's moving down as a rigid body. If you want to see, for example, if you want to see the shell, there's going to be very little movement. There's the shell triangle measure. Actually, it says 0. Now, why would that be? Completely 0. Oh, yeah, that's fine, because when you think about it, there's nothing wrong with it. When you think about it, if this is fixed, if this is fixed, this beam that connects the corner to this is not going to put any force on that because this was clamped, right? There's nothing wrong with this. This shell does not move at all. Okay, this is not lying. Does not move at all. And if you look at the stress distribution, the beam will have stress in it. Of course, you cannot plot the stresses in the beam. And yep, uh, this this shell does not go anywhere because the only thing that connects this to that solid object that moves is this beam, but that beam is coming to this uh, point that is fixed in space. Okay, so this shell does not see any displacement at all. There's nothing wrong with it. This is the way it was.